Welcome to video lecture on analog and digital electronics. In this session, I'll discuss about programmable logic devices like PLA and PAL. A programmable logic device, that is PLD, is an electronic component used to build reconfigurable digital circuit. A logic device capable of being programmed to provide a variety of different logic functions is called programmable logic device. Programmable logic device contains an array of AND gates and another array of OR gates. PLDs are semiconductor devices that can be programmed to obtain required logic devices. Device programmer blows fuses on PLD to control each gate operation. There are three fundamental types of PLDs. They are programmable read-only memory, that is PROM, programmable array logic, that is PAL, programmable logic arrays, PLA. Now, let us see the structure of three fundamental types of PLDs. The diagram A indicates the structure of programmable read-only memory PROM. PROM has fixed AND array and programmable OR array. So, fixed AND array is implemented using decoder. The diagram B indicates the structure of programmable array logic or PLA device. PLA device has programmable AND array and fixed OR array. The diagram C indicates the structure of programmable logic array or PLA device. PLA device has programmable AND array as well as programmable OR array. In general, in this diagram, yellow color block indicates the fixed array and the blue color block indicates the programmable array. In the previous session, I have discussed how to program a read-only memory. Now let us see what is programmable array logic or PAL device. A PAL device is a programmable logic device that has a programmable AND array and fixed OR array. This is the structure of a PAL with 4 inputs and 2 outputs. Here, X mark indicates that they are programmable and solid bullet indicates that they are fixed array. Here you can see the AND array are programmable and OR array are fixed. The input to the AND array are A, B, C, D and their respective complement. The outputs of OR gate are Y1 and Y2. In this PAL, the output of first 4 AND gates are the input for the first OR gate and output of next 4 AND gates are the input for the second OR gate. After studying an example of programmable array logic or PAL device, we can say that inputs of AND gates are programmable in case of PAL and they can generate only the required product terms. Inputs of the OR gates are not programmable. The number of input to each of the OR gate is fixed. The output of PAL is represented as a sum of product term. We have studied that PALs can be programmed by using the connection of PAL by a PAL programmer. Now implement following Boolean functions using PAL. Y3 is equal to A bar B C bar, Y2 is equal to A B bar C plus ABC, Y1 equal to A B bar C plus A bar B C plus A B C, Y naught is equal to A bar B C bar plus A bar B C plus A B C bar plus A B C. Now if I look into the expressions, I can see that all expressions are composed of 3 variables and I have to implement 4 expressions. Hence I have to draw 3 input and 4 output PAL, and the number of input to the AND OR gate are 4, because if I see the expression Y naught contains 4 terms. So choose the expression which has maximum terms, that many number of input should be there for the OR gate. In the case of PAL, the OR array is fixed. So I will draw the bullet symbol against the input of the OR gate. So first 3 AND gates output are the input for the OR gate 1. The output of next 4 AND gate, that is AND gate 5, 6, 7, 8 are the input for AND OR gate 2, which is indicated by this solid black color bullet mark. The input for third OR gate are the output of AND gate 9, 10, 11 and 12, which is indicated by this solid bullet symbols, and input for OR gate 4 are the output of AND gate 13, 14, 15 and 16, which is indicated by the bullet mark. The input for all the AND gates are the variable ABC and their respective complements. Now we will implement Y3. So the term for Y3 is A bar B C bar. Now let us implement Y3. Y3 is equal to A bar B C bar, which is implemented using OR gate 1. The input for OR gate 1 are output of AND gate 1, 2, 3 and 4. So let us implement A bar B C bar using AND gate 1. So draw X mark against A bar B and C bar of AND gate 1. So the output of AND gate 1 is A bar B C bar. So no more term in the expression Y3, hence the AND gate 2, 3 and 4 are unused, since they are the input for OR gate 1. So the output of OR gate 1 is nothing but Y3. The next term expression to be implemented is Y2. Y2 has 2 terms. Y2 is implemented using OR gate 2, for which the inputs are the output of AND gate 5, 6 and 7, 8. So we'll implement the term A, B bar C. So draw cross mark against A, B bar and C of AND gate 5. So the output of AND gate 5 is A, B bar, C. The next term is ABC. So draw cross mark against A, B, C of AND gate 6. Output of AND gate 6 is ABC. So no more term to implement. Hence the AND gate 7 and 8 are unused. So output of AND gate 5 and 6 are the input for OR gate 2. So the output of OR gate 2 is nothing but Y2, which is equal to A, B bar C plus ABC. Now let us implement y1. The first term for y1 is a b bar c, which is implemented using AND gate 9. So the term for 9 is a b bar c. So the output of AND gate 9 is a b bar c. The next term is a bar b c is implemented using AND gate 10. So draw X mark against a bar b c. So the output of AND gate 10 is a bar b c. Next term is abc, which is implemented using AND gate 11. So draw X mark against a b and C of AND gate 11. So the output of AND gate 11 is A, B, C. There is no more term for Y1. So AND gate 12 is unused. So input for OR gate 3 are output of AND gate 9, 10, 11. So the expression Y1 is implemented using OR gate 3. Next expression to be implemented is equal to y naught. So y naught is equal to a bar b c bar plus a bar b c plus a b c bar plus a b c, which is implemented using OR gate 4. Input for OR gate 4 are 13, 14, 15, 16 AND gates output. So term a bar b c bar is implemented using AND gate 13. So draw X mark against a bar b c bar. So the term for AND gate 13 is a bar b c bar. The next term is a bar b c, which is implemented using AND gate 14. So draw X mark against a bar b and c. So the output of AND gate 14 is a bar b c. The next term is a b c bar. So draw X mark against a b and c bar of AND gate 15. So output of AND gate 15 is a b c bar. The next term is a b c. So draw X mark against a b c of AND gate 16. Output of AND gate 16 is a b c. So output of AND gate 13, 14, 15, 16 are the input for OR gate 4. So OR gate 4 implement the expression y naught. Now we have completely implemented the expression y3, y2, y1 and y naught using PAL. If I see the implementation of the expression using PAL, some of the AND gates are unused, and if I see the terms in the expression, some of the terms are repeated, that is ABC is repeated in Y2, Y1 and Y0, but it is implemented 3 times in the PAL. So the drawback of PAL is some of the AND gates are unused, that is number of input for the OR gate is fixed. And second disadvantage is that if the terms are repeated in a set of expression, they have to be re-implemented. So that is the one more drawback of PAL. Now we will see what is programmable logic array or PLA. Programmable logic array is a programmable logic device that has programmable AND array and programmable OR array. The input to the AND gates are programmable and they can generate the required product term using AND array. The inputs of OR gate are also programmable unlike PAL. Output of PAL is represented by sum of product terms. This diagram indicates the structure of PLA with 3 inputs and 3 outputs. So there are 3 input ABC and their respective complement are the input for the AND gate, and there are 3 output X, Y, Z. Here the each and every slot is marked with X mark, which indicates that all the slots are programmable. That is, programmable AND array and programmable OR array is present in PLA. Like PAL, PLA are also can be programmed by fusing the each and every slot by the PLD programmer. So we will implement the following Boolean equation using PLA. The given equation y3 is equal to a bar b c bar, y2 is equal to a b bar c plus abc, y1 is equal to a b bar c plus a bar bc plus abc, y0 is equal to a bar bc bar plus a bar bc plus abc bar plus abc. So in order to implement the given equation, we need three variable PLA. So input for AND gate are three variable ABC and their respective complements, and we need four output OR gate. We have named the output OR gate as Y3, Y2, Y1 and Y0. So we have drawn a set of AND gates and four OR gates. So let us number the OR gate as 1, 2, 3 and 4, and number the AND gate as 1, 2, 3, 4, 5, 6, 7 and 8. Now let us implement y3 is equal to a bar b c bar using AND gate 1. So draw X mark against a bar b c bar of AND gate 1. So the output of AND gate 1 is a bar b c bar. So which is the input for OR gate 1. So in the line 1 of AND gate and OR gate, draw X mark. So there is no more term in y3. Now next implement y2. The term is a b bar c. So draw X mark against a b bar c of AND gate 2. So the output of AND gate 2 is a b bar c, which is the input for OR gate 2. So in the line of AND gate 2 and OR gate 2, draw X mark. So the next term in y2 is ABC. So draw X mark against A, B and C of AND gate 3. So the output of AND gate 3 is ABC, which is the input for OR gate 2. So in the line of AND gate 3 and OR gate 2, draw X mark. Here both AND and OR array are programmable. Now we have implemented y2 is equal to a bar c plus abc using AND gate 2 and 3 and OR gate 2. Next is y1. y1 is equal to a b bar c plus a bar bc plus abc. Now we will implement term a b bar c, but it is already implemented using AND gate 2. So output of AND gate 2 is the input for y3 3 OR gate also, that is third OR gate also. So draw X mark against AND gate 2 and OR gate 3. So the next term is a bar bc. So draw X mark against a bar b c of AND gate 4. So the output of AND gate 4 is a bar bc. So which is the input for OR gate 3. Next term is abc, which is already implemented using AND gate 3. So the output of AND gate 3 is also the input for OR gate 3. So in this line, draw X mark. So we have implemented all the three terms in y1. So next is y0. So the first term is a bar b c bar. So this term is already implemented using AND gate 1. So draw X mark against the line AND gate 1 and OR gate 4. The next term is a bc, a bar bc. So a bar bc is implemented using AND gate 4. So the output of AND gate 4 is also the input for OR gate 4. The next term is A, B, C bar. We have not implemented A, B, C bar. So draw X mark against A, B and C bar. So the output of AND gate 5 is A, B, C bar, which is the input for OR gate 4. So the next term is ABC, which is implemented using the AND gate 3. So output of AND gate 3 is also input for OR gate 4. We have implemented all the 4 terms in Y0. So we have implemented all the 4 expressions using PLA. Now see here none of the gates are unused unlike PAL, and also I can reuse the AND gate output for the OR gate. So these are the advantages of PLA over PAL. In this session, I have discussed what is PLDs. That is, there are 3 fundamental types of PLDs: PROM, PAL and PLA. We have understood what is PAL and PLA, and also we have solved the Boolean function implementation using PAL and PLA. Thank you.